This last section, we're going to talk about household circuits and how electricity is used in your house, and also a number of safety features that are in your house. First of all, 3 wires come off into your house off of a transformer. We've discussed transformers before in the previous chapter, but if you recall, transformers take high voltage, low current, and step it down to low voltage but high current, thereby keeping the power in equal to the power out. So there's no loss or gain of energy here. It's just you're transforming this high voltage to low voltage. And this allows you to use it more effectively in your household. So you step down from a few thousand volts, typically in like your neighborhood transformer, to 120 volts. Or if you're in some lines, you have these higher voltage primary lines, which can be 10 times that, 30,000 volts or so. Now, the wires that come into your house include 2 hot wires, and these wires operate at plus 120 volts or minus 120 volts, and a ground wire or a neutral wire. The way the transformer works is something that we'll discuss in the next chapter, but I have a little video here that talks about what makes up the transformer, and it actually does go a little bit into how it works as well when we talk about inductance. It's a fairly interesting video. It's only a few minutes long, so why don't you go and watch it here. Okay, so you get these wires that come into your house. Here are plus or minus 120. There's our minus 120. This is coming in from the ground. This is our neutral wire. So all these wires, these 3 wires, they go up to your transformer, and they come out of those bushings that they showed on the in the video. These go to a meter. This is the meter that has the little wheel that spins that the meter reader comes by and reads every so often. And then wires come in from the meter to your circuit breaker. Now, I'm just drawing one circuit here, but a household can have, 15, 20, even 30 different circuits that will operate different things. All right, but I'm just drawing one circuit, so just one component. So imagine you have one wire coming in. It goes to a circuit breaker. This is one switch within your circuit breaker box. All right, circuit breaker. The purpose of a circuit breaker, which we talked about before, is given by its name. It breaks the circuit. It's a circuit breaker. And then from that circuit breaker, on an individual circuit, you will go to a series of devices. This might be your radio, this might be your lights in a particular room, and this might be your microwave or whatever. Now, the household circuit is laid out in parallel so that a couple of things are true. First of all, that all devices operate at the same voltage. Because it would be very difficult to design electrical devices if you didn't know what the voltage on that device was going to be. And if you laid them out in series, like if this was your radio and this was your light, the voltage to your radio would be dependent upon whether or not the light bulb is on. And plus, if you take the light bulb out, then the radio is going to go off altogether because you would have a broken circuit. So that's the second reason. The second reason, I'm sorry, not the second reason here, but there's another, this is another reason for having a parallel circuit, is so if you remove one device, they don't all go out. On a particular circuit. We talked about that with Christmas lights, right? That used to be the way that they designed Christmas lights, was as a series circuit. And so if you removed one bulb, or if a bulb just went out, the entire circuit would go out. So we have a couple of things that are true for parallel circuits. All devices operate at same voltages because resistors in parallel have the same voltage. Also, on a given circuit, if you increase the number of devices, That is, you add your microwave, you add your radio, you add your heater, you increase the total current. All right, we talked about this before. If I have a parallel circuit that looks like this, I have currents that are going to each of these. I have a current here, a current here, and a current here. And the total current is equal to the sum of those three individual currents. And then if I add a fourth resistor, then that total current increases by the amount that I've added that fourth resistor. All right, we will pause there, and I'll pick up some of the other safety features of the house.